Bismillahirrahmanirrahim. My name is Malaika and I am from the Department of BS Chemistry. Today my topic of presentation is aldehydes and ketones. So organic compounds containing the carbonyl functional group are called aldehydes and ketones. Coming towards their physical properties, the polar nature of the carbonyl means dipole-dipole interactions will occur. Though carbonyl cannot form hydrogen bond to each other, the carbonyl can accept hydrogen bonds from hydrogen bond donors like water and alcohol. The implications of these effects are higher melting and boiling points than alkanes, lower boiling points than alcohols, and more soluble than alkanes but less soluble than alcohols in aqueous media. Coming towards the preparation methods of aldehydes and ketones, so the first method is ozonolysis of alkenes. In this reaction, first alkene reacts with ozone to form an unstable compound monoozonide, and then after further rearrangement it gives off ozonide. Then this ozonide is hydrated to give off aldehydes and ketones respectively. Second method is hydration of alkynes. Here, alkynes react with water in the presence of mercuric acid dissolved in sulfuric acid at 75 degrees C to form vinyl alcohol. Then, further rearrangement of this vinyl alcohol gives off aldehydes and ketones respectively. Only acetylene, when it is hydrated, gives off aldehydes. All the other alkynes, when they are hydrated, they give off ketones. Third reaction is oxidation of alcohols. So, this is the same which I have discussed earlier in the alcohol topic. Fourth one is Fiedel-Crafts acylation of aromatics. The main chain reaction is given. Coming towards its mechanism. First, the electrophile generation occurs, then this electrophile substitutes on the benzene ring, and then aldehydes and ketones are formed. Basically, aldehydes and ketones reactions and methods of preparation are discussed simultaneously and collectively because they have the same methods of preparation and they give off same reactions. Now coming towards reactions of aldehydes and ketones basically give off two types of reactions: base catalyzed nucleophilic addition reaction and acid catalyzed nucleophilic addition reaction. Here you can see the general mechanism for base catalyzed nucleophilic addition reaction, where in first step base abstracts the hydrogen from the nucleophile and nucleophile generation occurs. In the second step, this nucleophile attacks on the carbonyl group, and in the third step, this compound further reacts with water to form respective product. So there are five types of base catalyzed reactions that occur with the same mechanism. First, as you can see, the addition of hydrogen cyanide. So here hydrogen cyanide can be added to aldehyde or ketone in the presence of NaCl to form the respective product. Basically, the product here formed is formaldehyde cyanohydrin, or if there would be a ketone reacting with hydrogen cyanide, then it would be acetone cyanohydrin, or a respective name would be given according to the ketone group. Second is addition of Grignard reagents. So this is the same reaction that I have discussed in the previous topic. Third is addition of sodium bisulfate. So as you can see that ketones or aldehydes can react with sodium bisulfate to form the product. This product is basically bisulfite addition product. Fourth one is haloform reaction. So in haloform reaction, only acetaldehyde and methyl ketones react with halogens in the presence of sodium hydroxide to give haloform and sodium salt of the acid, as you can see in the reaction. Fifth is condensation reaction. So condensation reactions are the reactions basically in which two molecules of the same or different group combine to form a new compound with or without the elimination of a small molecule like water or ammonia. These types of reactions are called condensation reactions. It has two types. First is aldol condensation. So aldol condensation is a reaction in which two molecules of same or different carbonyl compound containing alpha hydrogen. Alpha hydrogen basically the hydrogen which is attached to the carbon atom which is next to the carbonyl group, combine together to form aldol or ketol, and it usually loses the water molecule. Main chain reaction is given. We'll talk about its mechanism. Now in the first step, the removal of proton is occurring from the alpha carbon of aldehyde to form a carboanion. Then the nucleophile attacks on the carbonyl carbon to form alkoxide ion. Here the nucleophile is the carboanion, and on which it is reacting is another aldehyde group. And in the third reaction, proton of water molecule removal of proton from water molecule is occurring, and alkoxide ion is formed. So basically, it completely agrees with the reaction conditions for the aldol condensations, that the water molecule is liberated. So the product formed is 3-hydroxybutanol, or aldol, can we say in the simple words. Now coming towards the Cannizzaro reaction, it is also a type of condensation reaction. So aldehydes having no alpha hydrogen atoms undergo Cannizzaro reaction, and it is basically a self-oxidation reduction reaction. So main chain reaction is given. Coming towards its mechanism, as you can see in the first step, hydroxide ion is acting as a nucleophile, and it attacks on the electrophile carbonyl carbon to form a complex anion. Then this anion transfers a hydride ion to second molecule of formaldehyde in the presence of negative charge on oxygen of the anion. Then the methoxide ion is acting as a base, and it abstracts a proton from formic acid to form methanol and formate ion. Now the formate ion in the presence of alkali gives a salt of acid, and the product formed is known as sodium formate. This was all about the base catalyzed nucleophilic addition reactions of aldehydes and ketones. Now coming towards the acid catalyzed nucleophilic addition reactions of aldehydes and ketones. So there are three types of acid catalyzed reactions. First one is polymerization of aldehydes. So both formaldehyde and acetaldehyde polymerize to give metaformaldehyde and paraldehyde, as you can see. Second one is addition of ammonia derivatives. It is a very simple reaction in which ammonia derivatives are added to aldehydes and ketones, and only a water molecule is liberated from the product. First, ammonia derivatives is hydroxylamine. So addition of hydroxylamine in the presence of addition of hydroxylamine to an aldehyde or ketone with a liberation of water molecule gives you the product like ethanol oxime. Then is phenylhydrazine. It is also a ammonia derivative, so it is reacting with the alcohol, aldehyde or ketone to form the respective product with the liberation of water molecule. It is known as phenylhydrazone. And third derivative is hydrazines. They also react with the same mechanism, liberate water molecule and form the respective product. Here it can be named as acetaldehyde hydrazone. And the fourth one is 2,4-dinitrophenylhydrazine addition into aldehyde or ketone. So here it can be named as acetaldehyde 2,4-dinitrophenylhydrazine. Third one is addition of alcohols. So simply alcohols are added to the aldehydes or ketones and form the respective product. Here this product is known as 1,1-diethoxyethane. Coming towards the applications of aldehydes, formaldehyde is a gas with 40% solution in water. It forms formalin, which is used in preserving biological specimens. Formaldehyde is used in embalming, tanning, preparing glues and polymeric products as germicides, insecticides and fungicides for plants. It is also used in drug testing and photography. When reacted with phenol, formaldehyde forms bakelite, which is used in plastics, coatings and adhesives. Acetaldehyde is largely used for the production of acetic acid and pyridine derivatives. Benzaldehyde is used in perfumes, cosmetic products and dyes. It is added to provide almond flavor to food products and also used as a bee repellent. Coming towards the applications of ketones, so the most common ketone is acetone, which is an excellent solvent for a number of plastics and synthetic fibers. In the household, acetone is used as a nail paint remover and paint thinner. In medicine, it is used in chemical peeling and for acne treatments. Methyl ethyl ketone, chemically butanon, is a common solvent. It is used in the production of textiles, varnishes, plastics, paint remover, paraffin wax, etc. MEK is also used as welding agent for plastics due to its dissolving properties, and cyclohexanone is another important ketone which is primarily used in the production of nylon. That's all about aldehyde and ketones. Thank you.